I think we beat the hell out of it.
Take that, dead horse. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 231. We'll be harnessing sparks, hacking food, and leaving breadcrumbs. This week in the news, I guess the superconductor that was a superconductor last week isn't a superconductor this week.
Does that make it like a not-so-superconductor, perhaps?
It wasn't even a medium conductor as far as I understood. I actually stuck my neck way out last week as a superconductor skeptic, and who's right? Me! 7 labs have tried to recreate the LK99 room temperature superconductor claims, and of the 7, 3 of them got the kind of same diamagnetism effects that they get, which is where it's hovering over a magnet, and the other 4 couldn't even get the diamagnetism. 0 for 7 in terms of superconductivity at room temperature.
Yeah, at room temperature. I did read a Chinese lab has reported they measured zero resistance, but it was at 100 Kelvin. It may be superconductive, but of course that kind of takes the wind out of the room temperature part of that, right?
But it makes it a regular superconductor. I mean, that's better than nothing.
That's actually pretty cold for a modern superconductor. There is a room temperature superconductor. It just needs like 1 trillion pounds of pressure on it or something, right?
You know, aside from it's August, let's get our funny science stories out. The best thing to come out of this is, I'll throw a link in the show notes, an open letter to pause random superconductor experiments. We call on all labs and kitchens to immediately pause for at least 6 months the making of conductors with lower resistance than copper, because it's going to cause the doom of mankind. And those of you who've been used to AI being what's going to cause the doom of mankind will think that it's a pretty funny read.
Yeah, it certainly seems like if you can just convince everybody not to do what you need to get your act together to get into business for, that's a pretty sound business strategy, right?
Exactly. Bah. Enough snark and sarcasm. Should we head on off to What's That Sound?
Oh, I think so.
This is a journey into sound.
What's that sound?
What's that sound?
Ooh, you're going to love this one. First of all, What's That Sound is a game. We play a sound, you guess what it is, you head over to hackaday.com/podcast, fill out the form, tell us what it is, and we will pick among the right answers and send a lucky winner a Hackaday podcast t-shirt. This week is the shortest sound ever.
Oh, wow, that is short.
You could play it multiple times.
It's the high octave A on a toy piano. I don't know.
Not bad, not bad. It's a musical instrument. If you know what that musical instrument is, head on over to hackaday.com/podcast. Fill in the form, give us your best guess, and we'll see who gets it right next week. All right, let's head on to the hacks. This week I wanted to start off with Noisey Keyboards Sync Ships. This one is a bit of an eavesdropping hack. A group of researchers, Joshua Harrison, Ehsan Toriani, and Maryam Memejad, built a neural network that could tell what keys you're typing from how they sound over either a phone call or a Zoom meeting. So the idea is if you're typing in a password secretly and you think nobody's seeing you, but you're in a Zoom call and they're hearing you, this group of researchers can figure out what it is you typed, and they get a fantastic accuracy rate of, something in the upper 90%. And I thought that was really, really cool. This sort of attack has been done before a number of times, and I think they're getting a particularly good result here because they're kind of asking the right question. They're kind of analyzing the sounds in the right way. But B, they're also using a neural network of the kind of transformer type like we've been seeing in the chat bots And here, what that means is that it can kind of look at a bunch of the keystrokes together and put them together, learn from one about the other, and that helps them determine what you've typed more reasonably. I didn't see in this paper here if they're having people type in random letters as keystrokes or if they're actually typing in words. Because my secret fear is that this model may be, seeing a few characters out of a word and then putting the missing ones together. Whereas if you had substituted other characters in there, it might actually trip it up. But anyway, the really cool thing, I guess, for me in this article is that what they did was they took the sound and they made spectrograms of it, and particularly Mel spectrograms, which is a spectrogram on the log scale. So they turned the sound into an image, right? And then used an image classification neural network to pull the typed letters back out of it.
Well, I think it was actually words. I don't think it was random letters, but from what I read, they were able to show that even when they were wrong, which was not very often, that they were usually only one keystroke away from where it was. So like if you thought it was an S and it was wrong, it was probably an A, a W, a D, an X. I don't know, maybe the angled one's E, Z, whatever,
right,
Q,
right.
Whatever. But, if you're actually doing plain text, it's kind of like Project Gunman, where the Russians had the Selectrics bugged in the U.S. Embassy, right? They couldn't tell, which angle the ball was at, but that got it down to 3 letters. And so you could figure out, they probably weren't typing Gridsblick Vork. They were
right.
typing send more missiles or whatever the actual thing they were typing. So I think they were typing real letters. And that would be a problem if you were trying to say skim random passwords, assuming people use good passwords, which is not a great assumption. But if you're just typing plain text and you want to know, the latest gossip, that's probably pretty effective.
Yeah, right? I guess we've seen these before. People have tried to do similar things by, using arrays of antennas to see if they can localize which keys you're typing, or people have done attacks that are based on a particular keyboard where this letter sounds like that and this letter sounds like that. And I don't know, again, if they were training on the same keyboard that they ran the validation on.
I wondered that too.
Ooh.
I wasn't able to figure that out. So if you had to train, that makes it much less useful. But you'd think it almost has to be, right?
Yeah, it's trained on a MacBook Pro. So I guess there's some hope there that if your victim is using the same laptop as you're in.
You would think with mass-produced keys, though, that if they're able to do this, there must be some variation between the keys, right? That you couldn't hear with, just yourself. But I can't believe that striking a letter in one place versus another place, that interchanging the keys wouldn't upset that in some way.
Exactly. I've always thought that there must be some reliable timing cues, too, in the way people type things. And the micro pause between when you type, a JK versus a JL or something.
I've often thought that for password recognition, right? If you're typing my password in and it takes more than a quarter of a second, it's not me, right?
Yeah, right?
And the cadence of the letters, like you say.
If you can actually type the password, it's not me because all mine are in a password safe.
Well, that's true too, but...
Which comes to bite you the one time that you actually have to literally type it in. And you've got
and it's 40 characters.
20 random characters. And it's man, worst ever.
Nothing like the joy of having to put in your Microsoft disk encryption keys, the rare times I boot Windows.
Right.
If you boot through Grub, for some reason, every time it goes, oh, I don't know who you are, so you need to decrypt your hard drive with the 128 character string from hell. So
anyway, I always love these kind of random side channel attack sort of things, and I think this is a particularly fun one. It's also doing it in a clever way, which is it's taking something that we've got neural net models that are super well tuned to do, and that is discriminate images from each other and classify images. And they're doing that with sound by doing it on the spectrograms.
Well, I love my clickety-clack keyboard, but I didn't realize it was going to open me up to basically Van Eck freaking. But it makes you wonder, too, if there's any historical value to this? Like, are there any archival videos of people like typing on typewriters where you could actually go figure out what they were typing? And is that important? I don't even know. Maybe that's not important, but it seems like somebody'd be interested in that. But I don't know if that's even possible, but it's just something to think about.
I like it. I like it. The FBI apparently used to do keyboard forensics back when typewriters all had slightly different type heads, right? So maybe this is that. Maybe they're doing that already.
Maybe. Well, my first pick of the week was from J.G. Piero, and its STM32 oscilloscope uses all the features. We've actually covered projects from this hacker before, and it basically makes oscilloscopes out of things like an RP2040, or in this case, an STM32. And, some of them have pretty impressive capabilities, some of them less so. This one, I think, has 2 channels at 1 megahertz. But that really isn't what's interesting to me. I like the STM32s, and it's a nice example. But it amazes me how far we've come because, when I started out, having a scope was an unheard of luxury at home, especially, right? You might have one at the office, and if you had one at home, it was some beat up clunker or, some ancient piece of hardware that required constant maintenance. So that was always a sign of somebody who was either really serious or really rich, as they say, oh, well, I have a scope in my shop, come over and we'll look at your thing. And now we're building them out of, $4 development boards, and they have features that actually would have been super great in those days even. So it's amazing. And if you actually want to go buy a commercial instrument, those are pretty affordable now too. I think it's one of the things that's really super interesting to me about that is that it should be ushering in an era of better understanding, because I always say that's the hardest thing about electronics is we can't see what we're doing. If you're a carpenter, you can watch a guy build a table and you can go, oh, I see how you built the table. Then when you're building yours, you can look at it and go, oh, this is a little off true. This isn't, we can't see anything, right? One board looks pretty much like the other board, electronically at least. And so really the only way we have the window into our circuits is these oscilloscopes and, some similar things, logic analyzers for digital or what have you. But such a fundamental thing to be able to watch that voltage go by in time and see the relationships between them on multi-channel scopes. And those have become very, very common and very easy to hack together. I mean, you can even get the little, not that it's a great thing, but you can even get the little circuit that plugs into your sound card and do audio on your PC screen. So, for 50 cents and something you already have, you can basically have some form of crude AC coupled scope. It makes me wonder, are we seeing more understanding of electronics in the generation that's had this forever? Or is it really just kind of become part of the background noise and doesn't really make a difference? I think it almost has to have made a difference, but it's hard to pinpoint it.
Definitely agree that a lot more people now have access to scopes than before. And I do think that's tremendously cool. Some of them are better, some of them are worse. This one, I have to say, just looking through the Hagged AIO project, there's tremendous care has been taken on the analog input side, and that gives me a lot more faith in how this thing works than a lot of the kind of simple microcontroller scopes you see before. Good attention to cleaning up the analog supply voltages relative to the digital supply voltages and making sure that, the horrible ripple that microcontrollers make doesn't make its way over to the analog side. I think it's actually pretty cool. And then there's just all sorts of fun fabrication details here. It's an extraordinarily detailed write-up of how this thing works. So you should really check it out if you're interested in doing anything analog. And then it's also got a nice UI and it's all running in is it FreeRToss?
I think so, yeah. And it's physically beautiful too. I mean, I'm sure it's a 3D printed case, but if that came in a box from China, you wouldn't be surprised, right? If
Exactly.
you paid, $50 for it or $100 for it.
Yeah, so this is really the sort of thing that, you could get one made for yourself anyway. It would not be very expensive. It certainly is going to be cheaper than even the cheapest of scopes you're going to buy. Of course, it's only got a megahertz of bandwidth. It's not going to put the $200 Rigels to shame. But if you don't need something that far, if you just, if you're just doing low speed signals, boom, this could get you set up for not much money at all.
Yeah, and I think his RP2040 one was 2 channels at 100 megasamples per second. So that was a lot. It's not that you can't build something better. I think it was just the limitations of what he had there. But yeah, it's just a good looking device. And, but again, I think what really struck me as interesting is just this essentially universal accessibility to oscilloscopes that we have now and how that has to affect almost everything. What was your first scope, Elliot?
Oh man, my first scope, this is what happens if you have an academic for a dad. My first scope was an old Tektronix. It might have been 60 megahertz scope, but it was
Luxury.
a tube scope, and you had to turn the thing on and it like warmed up for I don't even know how long before a signal showed up on that thing. But it was being thrown away by some lab in the building, and my dad picked it up off the dumpster and brought it home.
Well, you were lucky. And, even after the trace shows up, you were supposed to let them warm up a lot before you really did anything serious.
Yeah.
If you
This
wanted
thing
a measurement.
drifted like crazy for a long time, and I was only doing audio stuff with it, truthfully.
My first scope I bought off a ham. I was a ham radio operator also and still am, but it was an RCA, I think it was called a Service Master. And so it was, tubes, like you say, round screen, didn't have the grid. It just had like a vertical bar, and it had all this stuff specific to TV servicing on it. And I think it had just enough bandwidth to pick up, like the 2 megahertz or whatever, barely. I had that scope for a long time, and I eventually traded it to a physicist of all people who wanted a scope in return for something else because I had a Hitachi by that point. But those scopes cost a fortune compared to what you can get now that would just shame those scopes, right? It makes them look like trash, and yet you pay a tenth of the price. And then when you consider the buying power of money, probably 100th of the price, right?
All right, my next hack takes the form of a video from Teaching Tech. Enhance your enclosures with a shadow line. And this is a case of something coming across from the world of injection molding and finding a use in 3D printing. The shadow line. And if you think about the way any basically plastic enclosure you've taken apart recently is built, there's always that little gap, right? And if you put your screwdriver in that gap and you pry it open, you find out that there's kind of a lip that sticks over from the top part and under from the bottom part. And they kind of mate together like two L's do if you put them against each other. And the reason they do that with injection molded parts is that they are never flat. And if you tried to do it with two flat surfaces, you'd see light between them. It just wouldn't make a good fit. Teaching Tech's point here is that if you 3D print a box that you want to fit together, you are going to be experiencing the same thing. And he makes a demo and shows that it doesn't quite fit right and it looks kind of janky. And the other thing that this shadow line kind of offset ledges does is it gives you a way to register the two parts together. Like, if you slide them, they kind of fit when they match. And that just makes it easier to assemble. And, maybe if you're going to screw it together, it helps you align the things before putting the screws in. Just makes life a lot easier. Looks slick. And the point of the video is kind of showing you how this is a useful feature to put into your 3D prints, but also how you'd go about making them in CAD programs. And I think that's also pretty neat. If you read the comments, a lot of people are angry about this. Everybody who has a video game controller is like, that's that little, crack along the side where the Cheeto dust gets caught or whatever. And so not everyone loves the shadow line. I do admit, I do think they look kind of sweet, and having it kind of cover up your imperfections is always a good thing to do. And it made me think about other kind of techniques that we can take from big industrial production and use in 3D printing. I think Donald Papp, who wrote this one, linked to an article about using crush ribs in 3D prints, which is also a really interesting one. You can never print a perfectly round hole, but if you print little bumps on it, when you need to press fit something round into there, it'll align nicely. And that's another kind of industry trick that will help the home 3D printer. Yeah, I just always think these kind of tried and true, tested industrial tricks are good for us to at least look at and see if they make sense in a 3D printing context.
I can't help but wonder if people who are really dyed-in-the-wool fabricators probably look at us and all laugh, right? So just like
Sure.
in the computer business, you see where people go, oh, we have small computers now. Hey, what about virtual memory? And the old guys are going, yeah, we had that, you know. So I wonder how much of that happens here where people go, oh, you know, there's all these things we can do with our 3D printers. And the people who've been injection molding plastic for the last 40 years go, yeah. One of the things I think's even better about 3D printing, though, is you can do things that aren't necessarily economically feasible for mass production, right? So I'm always surprised when you see those clamshell kind of cases that snap together. They're usually one color because you just got a bunch of plastic pellets and you're using the same color. But, you know, why not go two-tone? Works for a Panda, right? You got black on one side, white on the other side. And that's one of those things that's probably not feasible to do when you're making 10,000 and you're trying to get the 2 pennies off that it cost you to have the second set done. But on a 3D printer, really not big deal to just change the color. I think there's a lot of mechanisms that we haven't been able to see fully used because they're just too hard to build that this is enabling as well. And so I think we're going to see a lot more people who have experience in other realms bringing things into 3D printing and other types of fabrication like that. And we're all going to learn from it.
Yeah, I think that's right. And I think there's also times when you shouldn't learn from them if you're doing 3D printing, because 3D printing really is kind of its own design challenge too. And I know we talked about this last week with the Z layer adhesion, making kind of a grain in 3D prints, since that enforces the way you have to print them. But then there's all sorts of other things, like in this video, he's talking about injection molding. And he says, oh yeah, the other thing you have to do if you're injection molding a part is you have to include draft angles. They have to be like slightly bigger at the top than at the bottom so that you can pull them out of the mold. And that's just something you don't even have to think about at all with 3D prints, right? Because you're doing additive manufacturing. Another thing that's really common is if you need to make an injection molded part stronger, you'll try to make it thicker. And that's not always a win for 3D prints either, because we have hollow infill. So maybe you need to make the perimeters thicker. But then you run into things like when you try to make the plastic too thick in injection molding, it gets glommy and it doesn't fill right and it doesn't cool uniformly. So they do all these things with ribs and stuff to, you know, to give the like thin walls more integrity. And that's something we also could do, but maybe it's not the optimal way. I don't know. There's just all of these neat, interesting applications where looking at industrial procedures, like some of them translate over really well, some don't. And I think there's just tons of fertile ground there for people to take apart existing designs, say, what's going on here? What are they doing here? And then can I use these techniques or maybe just not at all?
Eventually, you do reach some sort of equilibrium where some of the old techniques have mixed with some of the new techniques, and probably some of what's going on in 3D printing may even be leaking out into the subtractive world too. I don't know that, but you know, I think we'll eventually reach some equilibrium. I've really been fond of saying for a long time that people say, oh, one day everybody will have a 3D printer. And I'm thinking, I don't know if that's true, but I think eventually they become as common as drill presses, right? If your neighbor says, I have a drill press in my garage, you're not amazed.
Right? Yeah.
No one goes, oh, really? How is that? What's that like? It's just, yeah, you got a drill press, whoopee. And it's not something you necessarily use every day, but you use it a lot. And when you need it, you really need it. I think that's where 3D printing will go to, at least 3D printing the way we know it. You know, when you get to the Star Trek matter synthesizer, okay, sure, I want one of those in my house too. But I think for the normal 3D printers, we're a long way away from that. Okay, my next pick for the week was Sebastian, different etching strokes for different PCBs folks. I guess we have to give Dan Maloney credit for that title, not Sebastian, but it was kind of an interesting post talking about PC board fabrication. Sebastian kind of found ordinary things that he could mix together and etch his PC boards and not use ferric chloride. And I guess I want to say he tweeted it. I think so. Put it somewhere on social media. And this caused the usual outcry of you're doing it wrong, but it seems to have worked. So I don't know if it's really wrong. It's like everybody's got different ways to do things. Um, the reason I brought it up, though, is kind of interesting to me that this is an old process, right? I mean, people have been etching PC boards for longer than there's been a Hackaday. And, there's ferric chloride, there's sodium persulfate, there's, various and other, the drain cleaner and borax or whatever. I don't know. There's some chemicals that people like to mix together to do that. And yet I'm still struck by something I said a few years back and got a lot of angry comments about is, why are you still making PC boards today, right? And I mean, yeah, if you need them today, absolutely. And there's some cachet to that. But wow, when I can send away and in, a week or less for virtually no money, get a stack of beautiful boards with solder mask and silk screen and plated through holes and all the things that aren't good when I make PC boards, and I have made many PC boards, I've totally lost interest in making PC boards. Now, it goes back to the 3D printer. If I had the little machine that I could say, here's my Gerbers, I punch a button and a beautiful board pops out. Yeah, I'm all over that, but I haven't really seen anything that makes good on that promise, right? There's things that do, eat away copper and, mill it away and things like that, but it's just not the same. It's not the same as getting a nice, high quality, easy to solder, beautiful looking, commercial looking board in the mail. So I think that's kind of interesting too, that you have this mature technology that really should be getting less important, and you still have all these people going, you're doing it wrong. The other thing is I guess in some municipalities, getting a hold of dangerous chemicals is getting harder and harder and getting you under more and more suspicion. So I kind of enjoyed that somebody said buying that much hydrogen peroxide was going to get you on a hairstylist watch list.
Yep. It's funny because that's exactly my source of high test hydrogen peroxide is a friend of the family who is a hairstylist who's like, oh yeah, I can get you 10% hydrogen peroxide, no problem. I actually use a similar etching solution myself. I still make PC boards by myself, but not as often as I used to. I guess my situation is worse than yours because I'm in Germany and we have customs that make it really hard to get boards in from China. And, sometimes they take a random extra week-long delay up in, either Frankfurt or Leipzig for some reason. I don't know why. That's where they come in. That's where they get impounded. Takes me a while sometimes, but it's completely random. The extra delay puts a little bite in it.
I used to bring boards in from Eastern Europe, though. I would think that would be pretty easy from, and they're not quite as cheap as some of the China board houses, but still pretty cheap.
We actually have a couple good domestic fast turnaround suppliers too. So I should shout out to Eisler who actually does this. But yeah, I still make boards myself. I don't know what my problem is.
Well, and don't get me wrong. Like I said in that post, which was a number of years ago, people do all kinds of things you don't have to do. Some people want to, turn their brake rotors. And if you want to do it, that's awesome. But it's not like, well, I have a car, so I guess I better go invest in all the material to turn my brake rotors.
Exactly.
Because they're going to need it.
Yeah.
You go to Brakes or Us and they turn your rotors for you and you're done. And for most of us, that's a much better answer. And I think it's the same thing with PC boards. Do you really want to be a scientist, chemist to making PC boards, or do you want to design electronic hardware?
Yep.
I wrote a book about building PC boards, and I've done it a ton. I've done it commercially, and I've done it in my garage. And I think I still have ferric chloride stains somewhere on my patio. So,
all right, my last hack this week is a Hackaday prize entry, machining metals with sparks. And this is Norbert Heinz, who runs the YouTube channel Homo Faciens, taking on EDM, electrical discharge machining. And he's starting from really the ground up in what is kind of typical fashion for him. And this project is taking an interesting approach. Usually EDM machines use kind of very expensive high voltage generators and then spit out a thin wire that then makes electric sparks with the piece you want to work and eventually kind of erode through it. Here he's taking a slightly different approach and maybe less refined, maybe coarser approach. a drill bit has pointed edges, and so they make reliable sparks. But then when he does some tests to see if he can use the drill bit directly against the workpiece, he ends up welding it to it. And so his next step is to spin the drill bit as he's doing it, and that leads him to using a machine that can reliably position a spinning drill bit, i.e. a cheap CNC machine. The video we link to here is his kind of exploration of what happens with sparks and plasmas and high voltage. But in typical Norbert Heinz fashion, he starts off with kind of the least plausible way you could make this work, which is to just do it in air. And then he finds that he gets lots of spatter, and that using flowing air, so he tries to cool it by, blowing air on it. And that helps some, but you get kind of unidirectional spatter. And then he takes the kind of more commonly used course, which is to do it underwater, and then in addition with flowing water over the top. And from each of these different steps, you can kind of see a real improvement in the quality of the end result. It's making the hole a lot closer to the 1 millimeter size that the drill bit is, and it's also making it a lot more regular. And it's really neat. He's doing all of this with super cheap materials. I think he's using a TV flyback transformer for the high voltage source, and one of these really cheap 3018 style CNC machines, which honestly the motors on them are barely good for cutting wood and probably are good for spinning a drill bit and making electrical sparks. So it's a really cool experiment in how far he can push this low-tech approach, and I don't think we've seen the end of it yet, but I'm going to keep following along.
Yeah, I think that's really interesting, although I kind of wonder how much RFI that throws out all over your neighborhood, right? But
lots.
Just don't tell your neighbors, right? It makes you wonder. We get kind of stuck in these ruts, right? If you want to cut a piece of metal, what do? Well, you use a saw, you use a mill, you can use sparks. Oh, that's interesting, right? Or you've got water jet cutters, so it just makes you wonder if sometimes you shouldn't just have a cold drink, sit under a tree, and think about what are some weird ways you could do things that you think you already know how to do.
Right.
Because I don't think I would have sat and thought, oh, I could use sparks to do that. But maybe there's some other things like that are out there. Not that that's a new technology or anything, but somebody thought of it first, and it certainly wasn't me. I have a friend of mine who was obsessed with the idea that he didn't invent the weed eater because he thinks, it's the stupidest thing in the world. Take a piece of nylon, spin it around, and cut grass with it.
Ooh.
But somebody thought of it and made a fortune, right? But yeah, I always wonder, what are the things that we do every day that we just think, oh, that's how it works because we're, isn't that is it the Saffer-Whorf hypothesis or something? Is how we think it is, so it is. The trick is getting outside of that and seeing something else to do.
That's clearly a ground up kind of exploration of EDM here. I think even if he ends up with a machine that works but is kind of rudimentary, I will have at least learned a lot by following along with his experiments. So I'm super happy about that.
Well, it's funny that you mentioned high voltage type stuff because my next pick was a Magnetohydrodynamic Drive in the kitchen sink, which was some work that Jay Bowles has done. And Jay Bowles is pretty well known. I think his channel's called the Plasma Channel. I guess Tom Nardi wrote this one up, and I think as he put it, while Jay usually won't even get out of bed for less than a dozen kilovolts, but this is really interesting project as he just kind of whipped together a little MHD drive in his kitchen sink using really common materials and some very low voltages. So actually he was running at like 25 volts at 9 amps and even got some results at 5 volts at 1.5 amps. So, I mean, that's like USB battery power. I don't know why this really interested me so much other than, it's kind of a high-tech idea. If you haven't run into it before, it's that you can have a electric magnetic flow of water, if you will. And so if you watched The Hunt for Red October, the submarine had the MHD drive. Actually, one of the universities I went to, they had a big government boondoggle lab for doing MHD work. So there's been a lot of research over that for the years. This is something that you could just kind of put together. It's a couple of electrodes and the strongest magnets you can get your hands on, which, by the way, these days is really strong magnets if you go shopping. If you haven't looked lately, you can get quite a bit of magnets for fairly cheap now. I guess it's sort of like, the old experiments where you take a coil of copper wire and just lay it down on the battery and it makes like a simple motor kind of thing. I'm really fascinated by these things that aren't necessarily practical, but they really demonstrate how things work, both for education and just because they're just cool. Really enjoyed seeing things like that lay out these complicated topics simply. So you can't take your little copper wire motor and drive a car with it or, anything for that matter, but it still works the same as those big motors. There's just a lot more nuance into how the big motor gets made. Same thing here. I don't think anybody's going to, have the next boomer submarine built in their backyard using MHD from this video. But, it's basically how the technology works. It's a great way to understand it.
So I think I understand how this thing works. It's got some magnets and then it's got an electric field. And so you get kind of the magnet field cross the electric field and that pushes them along. Does this mean that the water has to be conductive? Does it have to be salt water?
I don't know if it has to be salt water, but surely it has to be at least somewhat conductive, I'm thinking. But realize just about all water is somewhat conductive unless it's just super pure. I mean, it's tough getting non-conductive water.
Okay, fair enough. And the other thing I learned from watching his video was that if you are doing something like this, you want to use brass instead of some other metal because the oxide that builds up on it is more conductive than it would be if you were, say, using copper oxide or something. So brass electrodes if you're going to be rusting them.
There's all these details on something like that. So I wonder, is that the science fiction story? Is the submarine chasing the other submarine and he's got an MHD drive, so you shoot a slug of compressed deionized water towards him and it stalls him. I don't know. I think that was a Larry Niven novel, wasn't it, where they dumped reaction mass in their Bussard ramjets or something.
Oh, nice.
Or something to poison the reaction. Someone in the comments will tell us which novel that was.
I think you just throw a lot of iron at them and see what happens. Yeah, but totally cool science project. Can't beat that. My first quick hack this week comes from Nexperia. It's kind of an app note or press release or something about the NBM7100 boost buck regulator. And this one's really cute because it targets a coin cell battery. And the title, of course, is Minimizing Stress on a Coin Cell Battery. And coin cells, you only get the rated milliamp hours out of them if you pull them out really slowly. And this boost buck converter also uses a capacitor so that it slowly charges the capacitor up. So if you have a peaky load like a microcontroller that has to go online every once in a while, it can even that out for you. So it's a really pretty sweet idea, and it's one that you could implement yourself. Next up, a video from Robert Murray Smith. 3D print your own Seiko-style magic lever energy harvester. This is just a sweet mechanism. It is an old one, comes from the 50s. It was used for winding mechanical watches automatically when you wear it on your wrist. It converts rotary motion in one way or the other into rotary motion in one direction only by use of two ratchets and a clever kind of eccentric mounted pawls or something. Yeah, exactly. You got to go check this video out. It's a really sweet thing. Last up, Fulvio 2023 Hackaday Prize, a reinvented solar tracker. This is a fun device. I think what I liked about it a lot, it has 2-axis motion and it achieves it instead of using geared motors. It uses 2 linear actuators and a third pivot in between them. Here he's tracking the sun, and so it goes up and down and left and right, tracks the sun over the day and then up and down over the seasons. But I could see this being used for a bunch of slow motion movement applications.
It's interesting that you had Robert Murray Smith as a quick hack because I have one of his videos also. He's always got interesting videos. It was a Hobson's coupler leads to a weird engine. And I hadn't run into a Hobson's coupler before. It's a way to join 2 shafts at a right angle and have one transmit power to the other. And it's all tied in with universal joints and Cardan joints, and the 3D printers really allow you to experiment with stuff like that, where it would have taken a pretty full-on machine shop to do that some number of years ago. I'm always interested because I'm not really a mechanical engineer, but I've hung out with enough of them. And when you hear things like a Belleville washer or these different coupling types, or of course, if you're not going to use a Hobson coupler, then you need a bevel gear, things like that. I always try to pick up a little bit of that because I'm pretty much so ignorant about it. I enjoy learning about that kind of stuff. It makes me feel like I'm learning something. My next hack, Lunduk had myth tested DOS can't multitask. And honestly, the article itself was pretty interesting as far as showing how you could actually have some multitasking on DOS that didn't depend on third-party software. But there was also things like desk view, concurrent DOS, and the comments on this one was very interesting. There were so many people who had memories of that time period. Actually, one of my books, DOS 5, A Developer's Guide, if that tells you how old I am, had a big section on how to write these terminate and stay resonant programs. And that was kind of the way to do multitasking in those days, is you loaded yourself high in memory, told DOS to tell everybody there was less memory than there really was, and then you'd hang on to interrupts to get your time on the processor. So it was just kind of a nice walk down memory lane, and it's one of those articles like we frequently have where the comments are at least as good as the actual post. And then last but not least is kind of one of these videos that you just kind of enjoy watching. It was Process X, and it was hacking fake food. So if you go into a Japanese restaurant and they have the models of the sushi or the egg rolls or whatever it is that you're going to eat, it turns out most of that is still made by hand. And there is a 71-year-old craftsman on this video using what I think is wax to make all these beautiful, heads of lettuce and rice and just shrimp tempura. And it's just inspiring to watch it. And it makes you wonder, we were talking about how the oscilloscope looked so professional and that all these different projects now look so good. It makes me wonder, what can I be doing better when this guy can take a ball of wax and turn it into a head of lettuce? What should I be doing to make my projects look better? But it's just a relaxing watch, if nothing else.
All right, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I wanted to pick Arya Voronova's Share Your Projects, Leave Breadcrumbs. And she's been thinking about how to make it easier for people to share their projects with other hackers. I think it's a great goal just by itself, and it's one that I'm particularly bad at. So I read these and try to take notes. This one, Leaving Breadcrumbs, is about taking notes and about how to make it easier for you as you're moving along through a project to take notes on how you fixed this bit or, how you got from here to there. It saves you time later if you have to debug it, and if you can make them visible to other people, of course, then, it's not just breadcrumbs or lab notes. It's actually like helpful documentation or, at least kind of proto-documentation for other people to get started and understand what you're up to. It's funny because a lot of the ways she's suggesting here are kind of the things you think about, like blogs and things that are kind of, or use GitHub or post it on whatever used to be Twitter. It's now X. And some of these are, kind of more or less public facing. And I think that's kind of the interesting take home for me here is that where I literally have a lab notebook where I write down stuff like this. And, these are kind of my breadcrumbs that, how I wired this up or, which pin does what, things I need to remember for later. Arya puts these things onto a blog that she runs herself. It's a WordPress blog, right? That's awesome because it makes it kind of instantly available to other people. And these days, it's not that much harder than writing it down in a notebook would be anyway. And, half the time I'm writing down something that I've just typed into a computer to begin with, right? So I might as well just cut it and paste it somewhere else. And so I think that's part of what's interesting here is just this idea for me that maybe I should think about kind of streamlining a flow where I get stuff into one place faster. Question is which place?
Hackaday AIO, baby.
I tell you, if you've been looking at what's going on with all of these kind of social media and shared platforms, right? Like Twitter/X is kind of going up in flames one way or another. Reddit is, used to be a place where
Angry.
people would put these sort of things, has become angry. If you're documenting it with photos, there's Imager, I guess. I don't know. I mean, there are more or less accessible ways to do this. But like you say, Hagged AIO, we have the stack. We have projects there that make it really easy to just add new logs. That might be a way to do it too.
And it makes it very discoverable because, if you have a personal blog, after your mom visits it 5 times, that's kind of the end of it. But if you're on Hackaday AIO or some of these other platforms too, don't mean to only Hackaday AIO, but people of like mind are going to find it. And that's what's really cool is when you start getting meaningful feedback from people that actually get what you're doing, as opposed to your Facebook friends going, thumbs up, that looks like you had a good time. It's like, well, that's not very useful.
Soldering is hard.
I got to tell you a dirty secret, Elliot. That's many of the reasons I write is that I don't remember anything. So, every Hackaday article I write, every Hackaday AIO page I make, every GitHub page I post, it's not really this altruistic sharing. It's that in 4 years, I'm going to go back and go, what were the commands to that monitor again? I don't remember. And I do that all the time. I look up stuff I've written and read it.
Yeah, before we leave this, I guess I should say I really like the breadcrumb idea, and that is you don't have to write the whole documentation now. You just have to kind of take notes as you go along, and that kind of lowers the activation energy to get your notes down on something. Arya's point is if it's a blog or a Hagged AIO project or whatever, it doesn't have to be finished yet. You can work on it incrementally and just use this as the place you're taking notes. When it does get finished, of course, boom, there you have it. Your documentation's done and it's finished. But this kind of, incremental documentation as you're going along is the kind of breadcrumb idea. And I think that's a good one too.
Well, my pick for the week was our own Tom Nardi's review of Beepy, a palm-sized Linux hacking playground. It looks all the world like a Blackberry, and it's not surprising because it's a genuine Blackberry keyboard, which if you're not old enough to remember when the Blackberries ruled the cell phone world, that was the mark of a real nerd, was to sit in the airport typing on your Blackberry all your emails. The board's actually not a computer. It's just a keyboard, a display, a couple other little odds and ends, and you still have to plug, I think it's a Pi 0W into it or something if you want it to do anything useful. What a cool platform. And it reminds me that I always think there should be more of this, right? I mean, if you think about it, we all live on abstractions. No matter what super hacker you are, you probably can't go grab copper ore, refine it, and draw it into wire, right? So you go buy your wire somewhere. And of course, now that I've said that, somebody will comment, well, I do make my own wire. But for most of us mortals, we don't draw our own wire, and we don't mix up carbon black to make our composition resistors. And, so there's all these abstractions that we all rely on. And the bigger the abstractions, there's positive and negative to that. But the positive part is that you can do more. So why don't we see more of these things? Why don't we see laptop shells that are hackable? And we're seeing a little bit of that. I think this kind of falls into that same category. Why aren't we seeing, there's all these handheld factors where you see things like people with the scanners and they're scanning your car coming in at the car rental place. Those are industrial machines and they're expensive, but why aren't we seeing hackable platforms like that? Because honestly, even if you don't think of it from the hacker point of view, if I could sell that piece of hardware to everybody developing rental car scanner applications, well, it's got to be cheaper for them to buy it from me than to develop their own, right? And so, that level of abstraction would enable a whole nother class of items. And then what's next? Well, you keep adding on to that, right? And so I think this is a great example of one of these high-level building blocks that I'm always surprised we don't see more of.
In case you haven't seen one of these before or you didn't follow the saga, this was a project originally known as Beepberry, and then they got a cease and desist from Blackberry, which seems unfair to me because, it is using a genuine, new old stock Blackberry keyboard for it. So
They could have bleeped out the berry and been the beep beep, right? So
now it's the Beepy. So fine by me. It's definitely looks like it's a do-it-yourself machine, right? Like, if you get it without the Pi Zero, it's obviously do-it-yourself. But even so, it doesn't come with a case. You have to 3D print one, although there's some pretty slick-looking designs in the one Tom makes. I'm sold. Yeah, the software is not entirely squared away yet, and so people are still working on some of that. It's, this is a device for hackers to play around with, but that said, it's really cheap, gets great battery life. It's got this really, I don't know, I am a sucker for alternative displays, and this one has that sharp transflective display that's got memory and looks really good in the sunlight. Just kind of fun. Sweet looking little device. Do I need one? Well, probably not. But does it make you want one? Probably also.
yeah, when has that been a criteria that you have to need something to get it, Elliot? I don't know. Tom did mention that I guess some people are reporting that they've had power supply failures on it, which look pretty bad. So hopefully they'll get that ironed out. Like you say, it's pretty early. I think there's a lot to do with this, but I hope we see more things like this, right? More generic building blocks that are not just a chip, or a little board that drives a motor, those are all great building blocks. Also, we got a lot of those, but where is our big user interface or industrial control type building blocks that you can have a lot of customization with? And this is exactly what I would want if I were building this kind of application.
That's funny you mentioned building blocks, because as far as I know, SQFMI, who made this, took the keyboard section straight off of Arturo 182's Blackberry keyboard project. So that's kind of fun too. I mean, they kind of took his module, combined it together with the screen and some glue, and added a really slick mounting option for the Pi Zero. I guess that has to be mentioned. It's got these funny little spring pins that clip into the Pi Zero. So instead, where it's got, that 2x20 pin header port or whatever it is, this one just nestles up against all of these little pins, and then you kind of screw it down on them to make contact. It's a nice strong contact, but it's not a permanent install either. So you can pull the Raspberry Pi out if there's a horrible Raspberry Pi shortage, and you can use it in other devices. That about wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you'd like to follow the links or leave comments, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, drop us a line, tips@hackaday.com. And until next week,
Keep those hacks coming.
everything is groovy. 7 science labs.
Yeah, I used to say I never got these, but after the Star Trek one, I can't say that anymore. So
Maybe it was me with the noise. That would be the worst. Into something that that was lousy. It achieves. I think that's where that has to end.